We're in a new unit, folks. And with this unit, we're kind of going back to middle school again and doing some transformations, similarity transformations. There's a lot of them are congruent transformations and all of those things. But yeah, so we're gonna hit these with some examples. In this first one, we're talking about reflections. The biggest difference between this in this class and what it is in, say, 8th grade math or middle school math or whatever, is we're potentially doing more transformations than what you may have learned in middle school, possibly, and we're also where our frame of reference is different. Let's jump into an example, and I'll show you what I mean. So in this first example, we have triangle JKL has vertices. These vertices, we'll label them in a minute. We're going to graph triangle JKL and its image in the line x equals -4. So what we're doing is, excuse me, the difference is, so in middle school, if you did this topic, then likely what you did was just reflected stuff over the y-axis or the x-axis, right? And so we just did it that. But what we're adding is reflecting the figure over a different thing. And so we're going to reflect it over this line. So let's start by just graphing JKL, right? So let's start with it. So J is at 0, 3. So right here, I'm going to put the dots, and then I'm going to go back and put the lines on there because it's going to be easier for me to do that. So J is right there. K is at -2, -1. So right here. And then L is at -6, 1. So -2, 4, 6, 1. So right there. And this is K. All right. So let me connect these dots real quickly. You can do the same with your ruler or whatever, right? So there is the original figure. So we're going to do its image on the line x equals -4. So I'm going to start out by dotting in this reflection line. Okay, so let me get a little bit smaller. So -1, 2, 3, 4. So I'm going to dot in this reflection line just so I have a frame of reference. Okay, that right there. So this is the line that we're going to take, and we're going to flip this over. Another thing, now you may already notice something else kind of new that you may not have done when you did this in middle school is this. You can see that we have one of the points, one of the vertices to the left of the reflection line and a couple to the right. So that was typically not something that you'd see in a middle school class either. You'd have the entire shape on one side, and then you'd flip everything over to the other side. But this is going to be a little bit different because we're going to reflect it. It kind of is going to, it's going to look like it rotated around this line. And so what I like to do is I like to kind of take them one point at a time. So if I reflect this K over this axis, then it was 2 over, and so it's going to be 2 over from where we're reflecting. So this would be, and typically we do our reflection, we call it, we do use this little prime symbol. It's got a little sideways tick mark, right? Kind of a in the air comma. So K prime is how we would say that. So there's K prime. So now if I take and reflect this J over this axis, then it was 4 over there, and so it's going to be 4 this way. So 1, 2, 3, 4. So J prime would be over here. All right. So same idea with K prime. So we're going to take, it was 2 over, and we're going to reflect it 2 over. So this, hopefully this is kind of review, and you've seen this kind of thing before. Oh, I labeled that wrong. This one should be K, but this one should be L. So this is L, and which makes this L prime, right? All right, so this is K prime. right? So then we can connect the dots just like we did. So now we have the graph and we have it reflected over the line x equals -4. So there's that type of option. We'll see all kinds of stuff like this in class. Now, the next and final example, we're actually going to just do 2 examples in this lesson, is something that is really important to understand. And so let me read it, and we'll get through it, and we'll show you what we mean and what we're going to do. So quadrilateral JKLM has vertices these, right? We'll graph them in a minute. And we want to graph JKLM and its image, J prime, K prime, L prime, M prime, in the line y equals x. So this time, instead of reflecting just straight across us, horizontal or vertical, we're reflecting across that diagonal parent function of y equals x, that linear parent function. And this is really important because this is the way inverse functions are defined. Inverse function is a reflection across that line y equals x. And so this is kind of an important thing to be able to do this. Okay, so let's start by doing JKLM. So J is at 2, 2. So right here, I don't remember what this is going to look like, so hopefully I'm labeling my labels in a good place. We'll see what happens as we go. All right, so K is at 4, 1, so right here. So there's K. Excuse me. And then L is at 1, 2, 3, -1, 2, 3. So there's L. Oops, not 4. There's L. And then M is at 0, -1, 2, 3, 4. All right, so that is M. And I'm going to connect those dots. So we've got kind of a, not a trapezoid, probably, but kind of like an almost trapezoid. I don't know. We could figure out what the slope of these 2 lines and prove whether it was a trapezoid or not, but we're not worried about that. So we want to take and reflect this across the line y equals x. So just like I did before, I'm going to dot in that reflection line. So for me, it's easiest to do this, right? So there is the line we're going to reflect this over, right? So it is going to reflect, instead of just this way, instead of just like, it's going to go this way. So you kind of got to turn your head sideways and see how we're going to make that work, right? And so that's what we're going to do. So the astute among you may have realized that I screwed this up. I put M at the wrong place. It should be down here. So I'm going to boop it into the correct place. Give me a second and I'll be right back and I'll fix it. Okay, so now there it's fixed. That's where the M should be, right? So now we've got to graph the reflection, right? Now we're reflecting across this line right here. So that's going to be, you can't see what I'm doing down here in front of me, but I'm trying to turning my paper, my screen down here at like a 45-degree angle, because it's going to be a lot easier to see what I'm doing. So that we're going to start by reflecting this J to J prime. Now, the interesting thing there is, since we're reflecting across this axis and it's on that axis, it doesn't move. So J prime and J are in identical locations, right? They're in the same place because it's on our reflection line. Now, K, to get to there, I'm going to kind of, the way I'm doing this in my head and thinking about what's going on is I'm kind of relating it to a fixed point. And so to get to this point, I've got to go over 2 and 1. So I've got to do the same thing to get to the other one. I've got to go over 2 and then over 1. So to get to K prime, it's going to be, oh, I did that wrong, didn't I? How about over 2 and over 1, right? So now we can see, and it's easy. This I may draw my line as I go to make sure that I'm doing the right thing. Even if you're like a crazy person and you're trying to do your math in pen, you may want to do some of these initial lines in pencil to make sure you're seeing what you're supposed to be seeing, right? And so you can see this reflects over this axis. If you turn it's harder to, like, I can see it easier looking at this thing. If I take and rotate, edit, image rotation, I want 45 degrees. And I look at it sideways, except that's the wrong way. Let me undo. Let me try doing that again. If I edit and what am I doing? No, image rotation. How about negative 45 degrees? All right. So now you're kind of looking at it the same way I'm looking at it, right? So if I kind of flip it and I'm looking at it along this axis, you can see what's happening. So if you turn your paper to that sort of y equals x line, you can see better what's happening, right? And so this line over here, to get to the M, to get from here to the M, I'm going to use a fixed point. So like a point where it crosses at a cross, kind of like what we've done before, to get to where I get to the M. So to get to the M, I have to go over 2 and over 2. So the same idea, 2 and then 2 will give us M prime, right? So that is going to be M prime right there, M prime. If I connect this to make sure I'm kind of looking, except that's not right. How about M connects to J? This to there, right? Does it look like it's flipped over? Yes, it does. I'm keeping my nice symmetry and all of those things is looking great. So to get to L from there, I could count it maybe from the M. So, I count up 1 and then over. So to get to the same idea, then I count up 1 and over 3. I just said over. And I get to L, right? So if I connect that to L prime, are we staying symmetrical? Yes, we are. There it is. So let me flip my thing back around. Positive 45. Okay. Oh, that's funny. It's shrunk it too. That's fine. That's fine. This is the last example. But there it is. There is our original and then the reflection across the line, y equals x. There you go. That is it for this lesson. We'll see you in the next one. We do some more transformations, more things, all the things. Bye-bye. I'll see you later.